Okay, so now we are talking about the decisions of managerial economics decisions. I'm not even going to use the word accounting here. This is an economic problem. It is a constrained optimization, right? If you remember from from microeconomics, all of microeconomics is about constrained optimization, maximizing utility given a budget constraint. Here, in this particular case, we are maximizing profit, which is a firm's version of utility, given the constraint of a resource of some sort. In the example, it's going to be a machine, right? So, this is econ. This is sort of intermediate econ right here, and what we are trying to do is maximize profitability given our constraints. And that's basically, I kind of got ahead of myself on the slide, right? So we need to, this is why we make you take microeconomics, this is why we make you take managerial accounting. This is just an incredibly important part of a manager's job. We need to choose our optimal product mix given our constraints. And a constraint is, if we want to have a definition of it, it's a limited resource, right? So for most of us, we have constraints. We have constraints in terms of our time, in terms of our budget, in terms of, I don't know, the number of minutes of texts you're allowed to do every month, right? So we all face constraints all the time, and we need to optimize given our constraints. That's the basics of economic behavior. Okay, so here is our setup, and I've set it up for you over here in Excel as well, because it might make it a little easier for you to get your head around how we're doing this. Okay, so instead of just reading the words, let's think about setting it up in columns and rows. So we have two different types of gears, gear X and gear Y, and we make a contribution margin of $25 for gear X and $10 for gear Y. So that's how much sort of, well, that's our contribution margin, so net of our variable costs. But then there's another cost to making these gears. The cost is how much time it takes in terms of the hours of machine time. It's an opportunity cost. It's not really an accounting cost. It's not going to show up on your accounting statements, but it is, in fact, a cost. It costs you, in this case, gear X costs you 2 hours to make, and gear Y costs you a half an hour to make. Okay, and so what we need to do, what we are asked to do, is figure out what is the contribution margin per hour of machine time. So for gear X, it's going to be 12.5. It's going to be $12.50 per hour of machine time, and gear Y, it's going to be $20 per hour of machine time. So just from eyeballing this, right, if you've got a limited number of hours that you can run that machine, right, you can only run 40,000 hours a year. So let's just add another line. Again, I'm not doing this the way that they did it in the, laid out precisely like they're doing it in the PowerPoint, but let's just think logically. So we'll say the, maximum contribution for 40,000 hours. So you could get $12.50 times 40,000, and I'm breaking my own rules and entering that 40,000 in there. So you get $500,000 if you just made all of gear X's, or you could make $800,000 if you focus entirely on gear Y. So anything you do with gear X is going to take down the amount of profit that you're making if you don't have to mix them up. This is why trade makes sense. Right? This comes to, what's called comparative advantage, and this idea that if a country is more efficient at making one product than another, they should focus entirely on that one product and trade, because they can buy more of the other product with the money that they make from focusing on the thing that they're efficient at. Let's see what the slides say. Okay, so here we have, our, the 1250 and the 20, like I calculated here, and then we can make $80,000, or I'm sorry, 80,000 units. We should make 80,000 units of gear Y, and none of gear X, to get us a maximum profit of $800,000. Maximum contribution margin. Okay, so we're going to continue down this path, right? So here's our same example, and we not only have a constraint on the maximum number of hours that we can get out of that machine, but we also don't want to produce more than 60,000 units of either one of these gears, right? So that's the maximum that we can sell. So, how do we do this? Well, there is a mathematical way to do this, which we're not going to go into in this class. But how you do this, if you think through it logically, right? So the first thing you do is, step one is produce up to the maximum of the more profitable product, and then what you do, right? Figure out how much time you have left on the machine, or how much more capacity you have on your constraint, on your limited resources, on your resource. And then step three is to calculate, fill up the time on the limited resource with producing the second product. So fill up the availability of the limited resource with the less profitable product. Okay, so how does that actually look in our example here? Okay, so the first thing we do is we figure out our contribution margin per hour for each of these, which we did, and then we figure out what is the optimal mix if we have a sales constraint, and what's the total contribution margin earned, right? So the first thing we do is we get 60,000 units of the, so step one, we get 60,000 units of gear Y, right? So it's 60,000 units times the $20 contribution margin, which gives us our, that can't be right. I'm sorry, I had a little mental problem there, and I debated whether to take it out of the video or let you see me making a mistake and then fixing it. And again, this is the beauty of Excel, right? I made a mistake. I see that this number can't be right, and the thing that I got wrong was I multiplied the units that I can produce by the contribution margin per hour of machine time rather than the contribution margin per unit. So all I got to do now, it's the beauty of Excel, I'll just go in here and pick up the right It's this one, D90. Not that one. D90, like that. You see how easy it is to fix mistakes? So now we have $600,000 contribution from the 60,000 units of gear Y, and then figure out how much more capacity we have. Right, so how much more capacity do we have? Well, it took 60,000 units. So what we're gonna do is subtract our total constraint on the machine hours, and then we're gonna subtract from that the 60,000 units times a half hour per unit. So that means we're gonna have 10,000 hours remaining. Right? This is contribution from gear Y. We have 10,000 hours remaining, and then step 3 is fill up the availability of the limited resource with the less profitable product. So we're going to take 10,000 hours, and we are going to use that for making our gear 2. So we've got 10,000 hours. And it's going to take us 2 hours per unit. Which gives us 5,000 units of gear X. And that means that that's going to yield 5,000 times 1250, no, times 25 in contribution from gear 2, which means that our total contribution from these two products is the 600 plus the 125, which is 725 total contribution from the two products. Okay, and the last thing that your slides talk about is the fact that you're never going to see just one constraint, right? Really, you've got constraints with your raw materials, with your demand, with your skilled labor, with all sorts of things. So you're going to always have multiple constraints. And to conduct profit maximization in the face of multiple constraints, that requires doing something called linear programming, which really isn't all that hard. I mean, it's hard to do by hand with matrix algebra. It's really hard to do by hand with matrix algebra, but Excel will do that for you. It's something that I do know how to do if anybody has any interest in sitting down with me and learning it. It's kind of a cool thing. So that is optimal product mix.